Welcome to the first lesson in Chapter 7 of the Pearson Geometry video series. This lesson is a flashback from transformations. Dilations are the only transformation that aren't rigid motions. Their size doesn't stay the same. Dilations can be created on a blank slate or on a grid. We're going to start with the blank slate. There are two methods. I'm going to walk you through the steps. Pause the video if you need to, then I'm going to show you an example. Method 1 is the ratio method. With the ratio method, you're going to start by drawing a line from the center of dilation through each vertex. Step 2 is to mark point A prime, the scaled distance from point A, on the ray that goes through A. Step 3 is to repeat for B and C, and then connect the points to form triangle A prime, B prime, C prime. If you need to, pause the video here and then start it up when you're ready for the example. Let's try this with example 1. First, we need a center of dilation. So we're going to put one right about here. And then also we need a scale factor. So this is a small triangle, so let's double it. So our scale factor is going to look like this. A dilation with a scale factor of 2 for triangle ABC. There's the notation. Okay, so since we have triangle ABC, let's go ahead and mark our triangle A, B, and C so that we know what A prime, B prime, C prime looks like. Okay, so the first step is to draw a line from the center of dilation through each vertex. Okay, so here's my center, and there's A is my first vertex, and I'm going to draw these lightly because the dilation is the main thing, not the lines that you use to draw it. Okay, so can you kind of see that through there? Then we're going to have another one that goes through vertex C from the center of dilation. And finally, we're going to have a third line that goes from the center through B. Okay, so we've got that going out there. Now we want to measure these lines. So from this center point to point A, we are looking at about that much. So we want it to be about out right here. Okay, so right here on the line, this much and then that much more. So we're kind of doubling the size. Okay, we're going to do the same thing with B. Okay, so if we measure this from the center to B, and we're looking at right about here. And then finally with point C, right about here. So we have our 3 points, and all we did was double the length. So from here to here, we made it here to here. From here to here, we made it here to here. And from here to here, we made it here to here. Now I've got 3 points, and I'm going to connect those points. So I'm going to connect these two out here, and then I'm going to connect these two, and finally I'm going to connect those two. And so we have our new set of points. So now this is A prime, B prime, and C prime. So we just doubled the size of our triangle. Okay, let's take a look at the parallel method. In the parallel method, we are going to start by drawing rays passing through each vertex from the center of dilation. Then we're going to mark point A so that it's the scale factor away from A, kind of like we did here. And then we're going to draw A prime, B prime so that it's parallel to AB. And then we're going to repeat that for A prime, C prime, and B prime, C prime. Okay, so let's start again with the center of dilation, which, by the way, these are usually given to you. And so are the scale factors. They're just not on here, so we have to add them. Now, this is a big triangle, so let's cut it in half. So this one is going to be a dilation of 1/2 from triangle ABC. Okay, so again, we're going to mark our triangle. So we'll call this A, and this B, and this C. Okay, so the first step is to draw rays passing through each vertex from the center of dilation. So this is actually, since it's getting smaller, it's going from the vertex to the center. So it's going to be about there like that. And then from vertex C, it's going to be right there. And then from vertex B, it's going to be right there. Okay, so now we need a point. We need a point that is, let's see, halfway, since our scale factor is half. So we have this line right here. Okay, so right about here, we're looking at halfway. We only need 1 point. All of this is going to go from that 1 point. So what we're going to do is make a line through that point that's parallel to AB. Okay, so parallel to AB is going to be right about there. I didn't make another point, I just stopped when I got to that line. Okay, we're going to do the same thing on the other side with AC. So from that point that we made, and we want a parallel line, so you're just going to kind of eyeball it. And it's going to go right there. And then finally, from those 2 points that you just made, we're going to go right there. And so we have our dilation of triangle ABC, which is triangle A prime, B prime, and C prime. Okay, now next on the agenda is to analyze the scale factor. So these scale factors work a little bit backwards. Okay, so when we're looking at these, we want to find 2 comparable sides. So the comparable sides are going to be like BC and B prime, C prime. And then you're going to go backwards. You're going to put the prime side over the original side. So when we do this, it's going to be A prime, B prime over AB. And that's just generally speaking. I mean, we can use A prime, B prime, and AB, but those sides are longer. So instead, let's go ahead and use BC and B prime, C prime. So we want to figure out how many this is. So we're looking at 1, 2, 3, 4, 5, 6. So this one is 6. And then we're looking at this one, which is 2. So we're going to say the scale factor is 6 over 2, which is equal to 3. So we have a scale factor of 3. So this one has been scaled up 3 times. Now, does that mean that this one is 3 times bigger than this one? No. It was multiplied by 3 this way, and it was multiplied by 3 this way. So it's multiplied 3 times 3, so it actually is 9 times bigger, even though it has a scale factor of 3. Okay, let's take a look at the next one. So this one we have 1, 2, 3, 4, 5, 6. And this one is 2. Okay, so this time we're looking at 2 over 6, which is equal to 1/3. So this one has a scale factor of 1 over 3. So does that mean that this one is 1/3 smaller? No, it's 1/3 times 1/3, so it's actually 1/9 of the original. Okay, let's take a look at the other side. So example 5 is like example 3 and example 4. So, what is the dilation factor for the quadrilateral in example 5? Pause the video, figure it out, and then start the video and check your answer. Okay, so you've had a chance to do it. So if we look at the prime side, which is 18, over the original side, which is 12, we can divide both of those by 6, and we're going to get 3/2. So our dilation factor for this one is 3/2. Okay. Now, we have one more. This one right here, example 6. Okay, so is this one going to be an enlargement or a reduction? So we're going from here to here. Okay, clearly, since it's getting smaller, it's a reduction. And how about that scale factor? What do you think the scale factor is? Well, from this one, this one is 2, this one is 1. So 1 over 2, we have a dilation factor of 1/2. That's not too hard, is it? Okay, so I said that you could dilate on a blank slate or a grid. Now we're going to look at the grid. So, given a dilation factor in ordered pairs, we're going to multiply. So the first thing we want to do is figure out what our ordered pairs are. So if we're looking at A, it's going to be 1, 2, and -1. So A is -2, positive 2, -1. Okay, and then we have B, and B is -1, positive 2. And we have C, and C is 1, 2, 3, and 0. Okay, so our scale factor is 3. That means that we're going to make this 3 times bigger. So we're going to multiply all of our points by 3. So A prime is going to be 2 times 3, which is 6, and -1 times 3, which is -3. B prime is going to be -1 times 3, which is -3, and 2 times 3, which is 6. And C prime is going to be 3 times 3, which is 9, and 0 times 3, which is 0. So these will be the ordered pairs that go with our dilation. Okay, now let's take a look at example 9. So for this one, to find the vertices, we have a dilation of 1/4. Okay, so we're going to need our original vertices first. So we have R, which is -4, 0. We have P, which is 8, 4. And we have Q, which is, 12, -4. Okay, and we are going to multiply all of those by 1/4. So, let's say R prime, and -4 divided by 4 is -1, and 0 stays the same. Okay, P prime, 8 divided by 4 is 2, 4 divided by 4 is 1, and Q prime, 12 divided by 4 is 3, -4 divided by 4 is -1. So we end up with -1, 0, 2, 1, and 3, -1. So all you're doing is multiplying your ordered pairs, both x and y, by whatever the dilation factor is to get your new ordered pairs for your dilation. Okay. Last kind of dilation we're going to go over is dilating on a grid when the center is not at the origin. So every time before, all we did was multiply our ordered pairs. Okay, now we have to take a look at where it is. So this one says vertices of, let's see, we have a dilation of 1/2 with our center of dilation at R. Okay, so that's important. That means that right here, this is where everything starts. Also means that this is not going to move. So if we are looking at RS is 1, 2, 3, 4, 5, 6. Okay, if we cut that in half, that would be 3. So we're going to go out 3 from R. So 1, 2, 3. Okay, so right there is our point. Going down from R to Q, we're going 1, 2, 3, 4, 5, 6, 7, 8. and we want to go half of that. So we're going to go 4. 1, 2, 3, 4. Okay, and then since T is the intersection going down from S and going right from Q, then T prime is going to be across from R prime or Q prime and down from S prime. Okay, so we can go ahead and connect these. And this is going to be Q prime and T prime and S prime. And we have our dilation from R. Okay, let's take a look at this one. Okay, with this one, we want to figure out what the center of dilation is. Okay, so over here, the center of dilation was R. That's the one we started from, and it didn't move. So here, it looks like A is our center of dilation. So A is going to be where everything starts from. Okay, now we want to figure out what the scale factor is. Okay, so let's say we have this line going across here, and then this line comes down here. Okay, so if we count up, we've got 1, 2, 3, 4, 5, 6. And then our original was up 1, 2, 3, 4. Which is 3 halves. Okay, if we want to check it the other way, then we can check how many over. So this one is going over 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So it ends up being the same. So it looks like we have a dilation factor of 3 halves. And we will write it like that. And this one is actually going to be from point A, so we can go ahead and write that down too and add that into our notation. All right, so all of that's pretty easy. You have 2 to try on your own, and then we will check these in class. Make sure you do them, because otherwise I'll count off when I look at the notes. So, example 12, you're figuring out the scale factor. In example 13, you're figuring out the coordinates after a dilation with a scale factor of 5. Okay, good luck with that. That's it for today. See you later.